Hey y'all, Steve here. It's been a long time since we've done any updates, but or at least YouTube videos. But fear not, we have been brewing beer. We had a busy summer. One of the things we did was make a tree house out in the back, 40, and then once we finished that, we brewed a beer called Treetop IPA. So one of the cool things about that beer is it's a fairly light-bodied IPA, but we use the homegrown Columbus hops for the beer, strictly for dry hopping. We didn't exactly get a big yield. This is second year on the Columbus hops, and once we dried them out, we had 2 ounces. So not a huge take, but maybe next year we'll get some more. So one of the things we did do this summer was upgrade the control panel, and it was more a it's not like we were missing any functionality in our system. What I wanted to do is consolidate some electronics into the box here and get rid of some of the external type stuff that we were using. One of the external devices that we were using was the boil controller. We use this standalone boil controller to control the boil. It's basically just one of those fancy solid state relays. And you know, this one more thing that was just like laying around on the deck when we were brewing, that I wanted to sort of consolidate. So we bought some more electronic devices and a cute little volt and amp meter, digital amp meter, and integrated it right into this little quadrant of the controller. We were able to shove the hot liquor tank and rims up into the top, being careful not to encroach on the space up here where the solid state relays are connected to the heat sink. And we got some different pumps so we could clean up some real estate there. This is the old controller panel right here, and you can see hot liquor tank and rims PIDs, and then we had a separate switch and indicator for both the heat cutoff as well as the pump. So we use these illuminated switches here now, so we don't have to worry about using a separate pilot light. And so we're able to shove that whole show right up there. And then we put the boil controller down in here. You know, the boil controller, all it is basically a potentiometer and a solid state relay. That's all there is to it. You can add a volt and amp meter just for the blink factor, or being able to dial it up to a repeatable value, which is pretty nice. And then we added this extra section here, and what this is this is the wort pump that we use to pump wort out of the boil kettle at the end of the boil. Okay, we pump it through the heat exchanger, which is down on the end of that of the enclosure here, and this, you all probably recognize this. This is a STC 1000. What I primarily use this for is just a temperature readout, and what we do is we have a special, if if I can find it. We have a special hose that we use to pump. This comes at the, this attaches to the output of the, what do you call it, heat exchanger, and goes straight into the fermenter. It's got like little holes, small holes punched into it, so it aerates the wort on the fly. And then we also have like a little T attached here that we stick the thermocouple into there. So we're able to measure the temperature of the wort on the fly as it goes out of the heat exchanger. And if it's too warm, we can dial back the pump speed, well, dial back pump flow. And we also have the option of increasing the water running through the heat exchanger. So between those two controls, wort speed and water flow speed, we can usually dial the temperature down to a pretty good target of 70 degrees for pitching temp. So it's pretty nice anyway. So that's what this is for. I also wired this up to 120 volts so that in the event that we want to control something, we could theoretically control the wort chiller or the fermenter chiller with this if we wanted to. We would just have to run this panel all the time. No big deal. Anyway, it turned out pretty nice. Stainless steel, as you know, is sort of a pain in the ass to machine. We used basically just a jigsaw and a drill, and matched all the cutouts up and inserted them. And then we had to do a significant amount of rewiring, which was the bigger pain in the neck. Just because we had a lot of new functionality and things were in different places, and the cables inside of it didn't quite, fit to the new locations. But it was a little bit of a job, but it turned out pretty nice, and I'm pretty happy with it. So it's not a bad box for the for what it is. It's small and compact, which is nice. You've seen some of them, right? They're like yay big, and like 8 inches thick. This is just 12 by 12 by 4 inches deep. So it takes a little bit of planning to fit everything in this, but I like the size of it, and it fits everything that it needs to fit. So this is basically what this is a Hammond something or another electrical box. If you can see the side of this here, it has knockouts for like conduit connectors, and we use those on the bottom here to run all our cables out of. But we don't use anything on the side here, and we just had to cut out a huge slot here in the very top so that we can attach the SSDs. I'm sorry, the SSRs to the bottom of the heat sink through the wall of the enclosure here, right? So it turned out pretty good. I'm pretty happy with it. We did have a little minor glitch on the maiden voyage there, but we were able to recover from that pretty fast, and in the brew day was, your typical, I think we can usually do it in about 5 hours nowadays, maybe a little bit less sometimes, depending on how many people are here to do cleanup. So that's pretty much it, and I hope you found that informative. If you have any questions or comments, feel free to post them on YouTube, okay? Thanks.